At Corrective, we manufacture a wide variety of fibers with different physical and chemical properties. An important parameter in the quality of a fiber is the measurement of a background loss. We sure receive a lot of questions about this. Let's take a look at what they are, what causes them, and when they need to be considered or not. Generally, optical fibers are made with glass as the primary material that is stretched into thin and long strands. They transport light, but they are not transparent to all wavelengths. Silica glass fibers have the best transmission window in the lower end of the infrared spectrum in what is called the near-infrared and shortwave infrared wavelength bands. An optical fiber is never perfectly transparent. You will always end up with less power than what you started with. This is what we call the background losses. The biggest part of this loss are caused by two mechanisms. The first one is scattering of light. When there are particles in the way, light can bounce off out of its way and exit the fiber. The second one is absorption, where the light can instead be absorbed in the fiber material, transforming into heat. Even in a perfect situation, the glass material has intrinsic loss components. The phenomenon of Rayleigh scattering has a major contribution where the particles in the fiber material itself scatter the light. This limit is there even in perfect glass, and with impurity, it will increase. Fun fact, this is the same phenomenon that makes the sky blue. Absorption is also always expected. Silica glass is not transparent in the ultraviolet or high infrared, and the edges of those effects are low, but still present in the standard infrared window. Additional losses will come from contaminants and impurities. The main contributor is OH molecules that can be present in the glass during the manufacturing of the fiber. They add specific absorption peaks. An optimal manufacturing process will aim to lower the concentration of OH to a few parts per million only, to get the curve as close to the theoretical limit as possible. Why do we want to minimize background loss? Because it brings noise in communication systems, heat in high-power lasers, and a loss of efficiency in general. It's also important to know the background loss at the exact application wavelength. For example, if you're in telecom, it's 1.5 micrometers. Background loss at other wavelengths might not be important to you at all. At Corrective, we aim to provide low background loss, particularly in the core of our active fibers to ensure performance and reliability. If you want to know more about this subject, visit our website or contact us.